Hello guys, let's have a quick look into the physical identification of sulfides. So basically sulfides, they are formed when we combine the metal or semi-metal with a sulfur, all right? And we've got complex sulfides and simple sulfides. Simple sulfides is when you have metal combined with a sulfur, whereas complex sulfides is when you are having two metals or more, sorry, combined with the sulfur. Okay. Please don't forget to like, share, comment, and hit the notification button below so that you get notified once we upload new content. Stay tuned. So, I've already mentioned what sulfides are, that these minerals, they are formed when we combine the sulfur with the metal, all right, and they are associated with ore deposits, okay, often formed through hydrothermal processes, magmatic segregation, or as products of metamorphism. But it doesn't end there. These minerals, these sulfides, they are very important for the researchers. For example, if you want to track what you call magmatic or magma rock interaction. All right. So, especially the people who are doing the research in the bushveld, they are using lot and lot of these sulfides. Okay. The sulfides, they can be identified physically. Okay. The first sulfide that we're dealing with today is pyrite, which is fool's gold. It confuses people because it looks like gold. All right. It has, in terms of color, it has pale brass yellow. And remember, if you are in terms of the luster, you remember that the luster is either metallic or non-metallic or non-metallic. So if you say metallic, you stop. But if you say it's metallic, you have to describe any further. So for all these sulfides, we're gonna be looking strictly at this metallic. So all the sulfides, they would have metallic luster, all of these things, okay? Because they will be shiny, they will be having this shiny appearance, all right? They will be having this shiny appearance. It means all of them, they are metallic. All right. But the interesting part about the pyrite is its crystal habit. We've got the cubic and or 12-sided. So is the key feature. This will help you to identify pyrite from get-go. You're just looking at this cubic or the pyrrhohedral or 12-sided crystal. Okay, and it's very hard. Okay, it's very hard. So that's why it's not easy to to scratch it with a knife, and also it does not easily get tarnished. So this is the pyrite. Okay, this is the pyrite. Um, and the streak is greenish black to brownish black. So usually it's dark. But the streak of pyrite, yes, is dark, but compared to the streak of a pyrrhotite, is still a bit lighter. So pyrrhotite will have a very dark streak as compared to the pyrite. So take home is you must be able to identify pyrite through its crystal habit, which is cubic, or sometimes 12-sided, which is pyritohedral, or also this thing is hard. Okay, it's hard, meaning it's not going to be easy to be scratched with the knife. So this is 12-sided crystal, showing that this thing is a pyrite, and it has the metallic luster. But the other thing, it's this cubic structure or cubic habit, right? This cubic habit that will help you to identify the pyrite. Never mind this one. This is the rhodochrosite. I just wanted to show you this and this dark streak. Okay, this dark streak. But like I said, compared the streak of pyrite as compared to the one of the pyrrhotite is still a bit lighter. Okay. So basically, that will help you identify the pyrite. Then pyrrhotite, the distinctive feature of you being able to identify the pyrrhotite is you must have a magnet. You must have a magnet, and if you have a magnet, if the sulfide get to be magnetized, if the sulfide get to be slightly magnetized, then you know, and obviously it is having a metallic luster, then you already know that I'm dealing with a pyrrhotite. A pyrrhotite, it's easily to be identified because it's magnetic, but obviously because of less iron content, it won't be that highly magnetic as compared to the magnetite. But if you can have the increased amount or high concentration of iron within this pyrrhotite, it might be highly magnetic. All right, but if it has less iron content, it will be slightly magnetic. But as compared to the other sulfides, such as the galena, the pyrite, and others, it's magnetic. That is the distinctive feature. All right. Like I said, in terms of luster, the all of these sulfides they're metallic in luster, and the pyrrhotite it has got the bronze or yellow to brown. Okay. And this one is not high, it's not that hard. It's not that hard as compared to the pyrrhotite. Sorry, as compared to the pyrite. Okay. So like I said, to test or to identify the pyrrhotite, you must have a magnet. So if it's highly or it's slightly magnetized and there's metallic luster, then you know for a fact that I'm dealing with a pyrrhotite. You know that I'm dealing with a pyrrhotite. Okay. And then in terms of color, obviously color, it might look similar to the one of the pyrite. Okay. But the streak, it will be much darker. Okay. It will be much darker as compared to the one, yeah, the pyrite. All right, so this is the pyrite, and this is the pyrite. It will be slightly magnetized, and obviously, again, it will have the dark luster, not luster, but dark streak. The distinctive feature of the galena is its density because of the presence of lead. So galena is very heavy. So it means the distinctive feature is the specific gravity or the density. By lifting the galena, you'll see or you'll feel or hey, this thing is very hard. All right, it's very heavy. Sorry, it's very heavy. So that is the distinctive feature, and obviously it will have this grayish a grayish color, or it will have the grayish color or grayish metallic color. All right, and then the streak it will be gray. Okay, and then you'd have cubic or the octahedral. All right, you'd have a cubic or octahedral, and the hardness is approximately around 2.5. So can now see that we can have the octahedral. So that is the giveaway that will help you to know that you're dealing with the galena. But the most important part is density. If it's heavy, then you know for a fact that this sulfide is a lead sulfide, which is the galena. And also, you're going to be looking at this cubic crystal habit. Okay? You're gonna be looking at this cubic crystal habit and this a metallic luster, and this lead gray color. Then the sphalerite, sphalerite is the easiest. Okay, why is it the easiest? Because the distinctive feature is if you put it under the ultraviolet light. If you put it under ultraviolet light, okay, provided that the manganese is present or the manganese is present in high quantity, then it will, glow orange. It will glow orange, like showing what you call the fire. That is to say, the distinctive feature of sphalerite is the higher dispersion. Okay, it's a higher dispersion, and also the resinous luster. The resinous luster, it means it's wherein the surface of this mineral, it looks like a resin or a plastic, or what you call it looks like an amber, or a dried honey, okay, or dried honey. So this is that dispersion. Can you see this is that dispersion? So this is the distinctive feature, and the fire kind of vibe. Okay, fire kind of vibe. But then you know that for a fact that I'm dealing with with the sphalerite. Okay. Um, that's why we say distinctive feature is high dispersion and the resinous and luster. All right, and the crystal habit is tetrahedral or dodecahedral. Okay, and the streak it's pale yellow to brown. Okay, it's pale yellow to brown. Sorry about that. And then luster, resinous to submetallic, resinous to submetallic. And then in terms of color, it can be yellow, brown, black, depending on the ion content. Now, can now see that we have got this resinous. Um, it has got this resinous, like I said. You have got this resinous luster. You've got this resinous luster. That's why we've got the resinous to submetallic, and it has high dispersion. It has high dispersion. Can you see? It has high dispersion. It means if you were to put this under ultraviolet light, and then it will glow and it will glow orange. Okay, now it will show that this is what you call is what you call the sphalerite. Okay, and then can you now see that it's a resinous. It has got the resinous luster, or it looks like an amber, or it looks like a dried honey. Okay, so basically that is that. This will help you identify them as sphalerite. And the chalcopyrite. It is brass yellow with a greenish tint. It means when you expose this thing to oxygen, it will tarnish. Okay, it will tarnish. And then um, the streak is black to greenish. Okay, black to greenish or black, and then we've got tetrahedral, but sometimes it's massive in terms of the crystal habit and hardness ranging between 3.5 to 4. But the most distinctive feature of this is it is softer than the pyrite. Okay, it is softer than the pyrite. It means you'll be able to scratch it with you'll be able to scratch it with a knife or steel nail. But now, because of the presence of the carbon, because of the presence of carbon, you not carbon, sorry, but copper, this it will tarnish. This it will tarnish. So you must always understand that it will often tarnish. So we expect to see a little bit of play of colors, but obviously not compared to the play of colors that are dominant in the bornite. All right, so we're also gonna see the play of colors, but I'm sure you must be wondering why are we having the play of colors. So, for example, in the bornite and in the bornite and this chalcopyrite. Okay, this is because these minerals bornite as well. Okay, bornite as well. So bornite and chalcopyrite, they are copper ores. Okay, they are copper ores. And then what's happening is because of what you call thin film interference. Thin film interference. So what's happening with this? We know that during the phenomenon thin film interference, we're gonna see what we call tiny lenses. So what's happening with these tiny lenses is we're gonna expect to see splitting and a reflection of light. So if we are splitting the light and they get to be reflected, then now you would have different wavelength of light which interfere with each other. Then during that interference, some of this wavelength of light some will amplify each other, and then some will cancel each other. Now, that process when the wavelength of light they are interfering, canceling and amplifying each other, they produce a vivid iridescent color, like blue, purple, and green. That's what you call them play of colors. You're gonna see that in chalcopyrite and more in bornite. That's why a bornite is what you call a peacock ore. But now, this chalcopyrite is also gonna show a bit of play of colors, provided if it's tarnished. Okay, if it's tarnished, if it was exposed to oxygen, then it will show that play of color. But now, like I mentioned, it's relatively softer as compared to the pyrite. So, what is the distinctive feature of this? What is the distinctive feature of this chalcopyrite? Is that play of color, but it won't be that pronounced. It will just be a little bit. Okay, but you want to see more of this inside the bornite. So this is the distinctive feature. Okay, so but if you were to look at the chalcopyrite, which is not tarnished, then the distinctive feature, it will be its softness. Okay, it will be its softness, but not only that, but a brass to yellow. Okay, it will be brass yellow basically. Okay. So if you can check over here, this is without tarnishing. Okay, the a larger portion of this is without tarnishing, and then showing brass yellow. But if it gets to, tarnish, then the distinctive feature, it will be this play of colors. But in this play of colors, you can see they are not pronounced. They are not pronounced, or they are not dominant. We just see this. We just see this purple and green colors. Then you call this iridescence. Then arsenopyrite, it's the complex sulfide, because of we have got two metals which are combined with sulfur to form a sulfide. But now this one, the arsenic, is very toxic, but is the key thing, is the key mineral or key metal which help identify the arsenopyrite. Because of the arsenic, it smells like garlic. It smells like a garlic. So if you want to know that you're dealing with arsenopyrite, you must smell this. But provided you can only smell this if you are in the environment with good ventilation, and you must always avoid a direct inhalation, because this thing is toxic, it's dangerous. Okay, it's dangerous and it's poisonous. So, if you will suspect that I might be looking at the pyrite, arsenopyrite, you must have the remember arsenopyrite in terms of color, it's like that of the galena, but obviously it won't be heavy, but it's like that of the galena. It's a bit silvery. Okay, it's a bit silvery. Okay. Is that like that of our galena, but the distinctive feature is it will be the streak. It is black to dark gray. It is black to dark gray. The distinctive feature is the streak, and also not that. But if you're to sniff at them arsenopyrite, especially if you can break it a bit, then you smell the garlic. Okay, then you know that you are dealing with the arsenopyrite. Okay, and that's that about the arsenopyrite. Show you. Let me show you quickly. All right, so the distinctive feature is this shape. Is this shape? Is this shape? That is to say, sharp wedge-like crystal is there. Obviously, the distance. Beside, if you don't want to use streak, you can use this sharp wedge-like crystal. Okay, is the distinctive feature. You see, we have got this sharp wedge. Okay, you have these sharp wedges. Okay, we've got these sharp wedges. But in terms of color, it's more or less like that of galena. But obviously, galena to be more heavier than this one. And then this one, you will see it with this wedge shape. All right. Then this wedge shape, it will easily help you to know that I'm dealing with the arsenopyrite. But not only that, but if you are in a good ventilated environment, then you can also break it a bit and try to sniff, and then you'll smell a garlic. Okay. Then the bornite, which is the last the sulfide that we're going to be dealing with today, we call it a peacock. Or I've already mentioned that the bornite and the chalcopyrite, they have got the play of colors. So the play of colors in the bornite, it's more pronounced. That's why we say it's a peacock or. So you're just looking for the colors of a peacock. Okay. So fresh surfaces are copper. Okay, okay. Fresh surfaces are copper, red or bronze, but it transitions to an iridescent purple, blue, or green colors. Okay, peacock-like colors. And so in terms of color, just look at the iridescent purple mixed with blue and greenish. And then his streak is gray to black, and then the cleavage is very poor. So if it's very poor, it means it has got a fracture. It means now it breaks unevenly. Okay, but in terms of the density, it ranges between 4.9 to 5.3. It is moderately heavy. But this one, it's a giveaway. You just look at the play of colors. You just look at these peacock colors, and then I know that I'm dealing with a bornite, but it's softer. Okay, it's relatively soft, so you can scratch it easily. So it is relatively soft, you can scratch it easily. So the distinctive feature, it will be the play of colors. Okay, so this mixture of bluish, but the play of colors, bluish, purple, and greenish. All right, mixed together, giving us what you call giving us what you call a peacock color, like that's why a bornite is what you call a peacock. Oh, okay. So that's it, folks, about the sulfides. So when you are in the lab, you must from get-go, you must be able to identify what kind of sulfide you are dealing with. Each and every of these sulfides, they've got their own distinctive features, and these sulfides, they are very important. The sulfides, they are very important to be understood because they are usually associated with gold, silver, and other metals. Okay, so that's why you must understand these sulfides. So each and every of the sulfide, like I mentioned, it has got its distinctive feature. What is the distinctive feature of the bornite? It will be the play of colors. It will be a play of colors, which is what you call the iridescent. And then in the chalcopyrite, it will be there, but it won't be as what we observe in the bornite, but it will be there. But if you're not looking at the fresher a chalcopyrite, if you're looking at the fresh chalcopyrite, then the distinctive feature, it will be the streak. Okay, it will be the streak, and also the shape or the color as well. But now for the galena, it will be the density. For pyrite, for pyrite, it will be that cubic or that 12 sides. And for the arsenopyrite, it will be that smell and the wedge shaped a crystal habit. So that's it, folks. Thanks for joining us today. If you haven't yet subscribed to our YouTube channel, please, you are more than welcome to do so. Please don't forget to like, share, comment, and hit the notification button below so that you get notified once we upload a new content. I'll always like to say cheers.